Auxiliary views. In the previous video, we discussed projecting an inclined surface of an object on a 2D screen. We have got all possible ideas, method to project an inclined surface. Auxiliary view is the terminology to project the inclined surface of an object. In this video, we are going to solve some problems in engineering drawing, so that we can get the idea about projecting auxiliary views and be able to apply it wherever needed. A square pyramid of base 38 mm side and axis 50 mm long is freely suspended from one of the corners of its base. Draw its projection when the axis as a vertical plane makes an angle of 45 degrees with a VP. First, write down the given data on a drawing sheet. Base side of square pyramid is equal to 38 mm, axis length is equal to 50 mm, axis is inclined with VP at 45 degrees, so first we will draw its initial position. First, we will draw the top view of the square pyramid. The top view of the square pyramid will be a square shape. It is a problem that the square pyramid is suspended freely from one of its corners, so we will make a square from its corner below XY. Draw a square ABCD in the top view, each side measuring 38 mm and angle between each side is 90 degrees. In this condition, we can see that the AC diagonal is parallel to XY reference line. This is the top view of the square problem. Now, we have to project its front view. The front view if the square pyramid is triangular in shape. Shift the point A', B', C', D' on line XY by drawing construction lines from the top view of step 1. Now give axis length is equal to 50 mm to draw O', P' is equal to 50 mm. Then join O', A' and O' C'. The obtained triangle is the front view of the square pyramid. Now mark centroid G' on axis O', P'. We can mark centroid at the intersection point of the medians, which are drawn from vertex to midpoint of opposite side. After marking G', join A' with G'. Now we have to project an auxiliary view. For that, draw a reference line X₁Y₁ parallel to O', C'. Then extend the construction lines from O', G', B' and C' such that extended lines are perpendicular to X₁Y₁. Project the top view and front view on that extended line. This is the first auxiliary view. Shift every point on extended lines by measuring its distance from top and front views. Now we can get an auxiliary view of the square pyramid, but the axis still remains parallel to the VP. And in problem, it is given that the axis is inclined at 45 degrees to VP. So draw X₂Y₂ such that it is inclined at 45 degrees to X₁Y₁. Then extend the construction lines from A', B', C', D' and P' such that these extended lines are perpendicular to X₂Y₂. Now shift the points from first auxiliary views in these extended lines. Name the apex as O1' and base square as A1', B1', C1', D1'. These points can be shifted by measuring distance between them by using a compass. Join these points to project it as a square pyramid. We cannot see the back portion of the square pyramid, so draw O1', B1', B1', A1' and B1' C1'. This is the final auxiliary view of the problem. In this view, the axis is inclined at 45 degrees and it is projected in the auxiliary plane X₂Y₂. This is how we can project an auxiliary view of an object. We have studied how to solve problems with an auxiliary view. Now we see what are the benefits of auxiliary views. So in auxiliary views, we can have the following advantage. The true shape of the inclined surface of an object can be projected. This view requires fewer steps as compared to orthographic and isometric views to project the true shape of the object. This view gives the clear configuration about the surface which cannot be projected using principal views, top, front and side views. So in this video, we have solved one problem regarding auxiliary views, so now we can easily project inclined 3D objects on a 2D plane. We have completed orthographic, isometric and auxiliary projection in the previous videos.